Let's solve some problems based on finding area of a polygon. In this figure, we have a polygon, and then we have another problem where we have this figure, and this is also a polygon. In both these two cases, we have to find the areas, the area of this figure and the area of this figure. But there is one problem. Do we have any such formula that we can use and tell directly that what will be the area of a given polygon? If that is not a general quadrilateral, if that is not a parallelogram, if that is not a rhombus, not a trapezium, not a rectangle, not a square, and not a triangle. If the polygons are none of these, then how will you tell the answer? We don't know any formula, right? But these are also polygons, and we can use these polygons in order to tell the areas of such complicated figures. Let's discuss its theoretical portion real quick. So imagine that you have these two figures, right? And this is a polygon. In this case, we have a pentagon, and in this case, again, we have a pentagon. Two pentagons, but different shapes. So if we take this vertex and if we draw a diagonal connecting these two vertices, and then another diagonal connecting these two vertices, right? So can you see here, you have now actually three triangles. You have three triangles, and if you know the height of each of these three triangles, then you can easily tell the area of this polygon by calculating the areas of these three triangles, right? If you know these three heights of these three triangles respectively, then you can tell the answer. In the same way, here, if we take a different approach and if we draw this diagonal and then we draw a 90-degree from here, let's take with different color, a 90-degree from here, from this vertex on this diagonal, another 90-degree from this vertex on this diagonal, and then you can clearly see here now, if these two line segments make 90-degree with this diagonal, then you have one triangle. Second number is a trapezium. How trapezium? These two lines, since these two line segments are perpendicular on this diagonal, therefore these two line segments are actually parallel, right? And these two opposite sides are non-parallel. That makes it a trapezium. So a triangle, a trapezium, then third number is another triangle. It's also a triangle, and the fourth number is also a triangle. So if in this case you know the height of this triangle, then you can quickly tell the answer. How? Area of this triangle plus area of this trapezium plus area of this triangle plus area of this triangle. Then you can tell the area of this polygon. The same thing you are going to use here, right? So let's begin now. Polygon ABCDE is divided into parts as shown below. Find its area if AD is equal to 8 centimeter, AH is equal to 6 centimeter, AG, AF, and perpendiculars BF, CH, and EG. So values are given for different line segments. Using this, you have to calculate the area of this polygon. Let's begin. Let's start from the rightmost triangle. This one, triangle CHD. Triangle CHD. So in this triangle, if you look at this triangle, then the formula to calculate the area of the triangle, of a triangle, is half multiplied by base. So in this case, base is what? Base is HT. Why? Because CH is perpendicular on HT. So the line segment HT will be the base, multiplied by height is what? CH, the perpendicular line segment, CH. Okay, so do we know the value of this HT? We don't have any such value here which can tell us that what's the value of HT. So let's calculate it. So HT, this HT, the line segment HT is actually what? The line segment AD, whose value is given here, that is 8 centimeter, minus AD minus AH, whose value is given here. So if you subtract the measurement of AH from AD, then you will get what? HD. AD minus AH is HD. So this gives you what? What's the value of AD? AD is 8. What's the value of AH? That is 6. So this is 2, right? So you get 2 centimeter. What's the value of CH here? That is 3. That is given here. So at the place of HD, half multiplied by HD, you put 2. 8 minus 6 is 2, multiplied by what's CH? CH is 3. So you get 3 centimeter squared, right? Okay, now let's come to this trapezium. Why this is trapezium? CH is perpendicular on AD, BF is perpendicular on AD. That makes these two line segments parallel to each other, and these two opposite sides are now non-parallel. That is clearly visible. If you can focus here, if you pay attention, these two, that is BC line segment and FH line segments, these two are non-parallel. Now, this is a trapezium. So the area of trapezium, BF, let's call BFHC, will be what? Half multiplied by height. What's the height here? We know that the height in a trapezium is actually the perpendicular line, the measurement of the perpendicular line segment between two parallel lines. So BF, CH are parallel, and FH is actually the perpendicular line segment, the straight line segment, right? That makes, why it is straight? Because this is 90 and this is also 90. So if a line segment is making intersecting two line segments at 90 degrees, it means that it's a complete straight line. That makes this the height of this trapezium, right? So the height of this trapezium is actually the straight line segment that's making 90 degrees with BF and CH, that is FH. So this is FH multiplied by the sum of two parallel sides, that is the measurement of BF plus the measurement of CH. Okay, do we know the value of FH? No, we don't know the value of FH. Then how to calculate it? So that's simple. In order to calculate the value of the line segment FH, we know the value of AH, that is 6 centimeter. And if you subtract the value of AF, do we have AF? Yes, we have AF here. So AH minus AF, AH minus AF will give you FH, right? The measurement of AF subtracted from AH will give you FH. So from here, what's AH? AH is 6 centimeter. What's AF? AF is 3 centimeter. You get 3 centimeter. Now, you have this value of FH now. We can put here. And do we have the values of BF and CH? Yes, we have these values. So remember that this is 3 centimeter. So calculate it. This comes half multiplied by 3 multiplied by BF plus CH means what? BF is 2, CH is 3 centimeter. So 2 plus 3 is 5 centimeter squared. That's the area. If you calculate it, you get, this is 6 minus 3 is 3. Okay, so this is 15 divided by 2. That makes it 7.5 centimeter squared. Now, the triangle BFA, the area of this triangle BFA will be half. What will be the base? AF. What will be the height? BF. Okay, so this is, we know the value of AF because it is given here, that is 3 centimeter. So half multiplied by AF is 3 centimeter multiplied by BF is 2 centimeter. So if you solve it, you get 3 centimeter squared. Now last, this big triangle in the lower portion, right? So the area of triangle AED, this will be equal to half. What's the base in this case? AD, the line segment AD, multiplied by, what's the height? Height is EG, the line segment EG. So if you calculate it, this is half multiplied by, what's the measurement of the line segment AD? That's given here 8 centimeter, multiplied by, what's the measurement of the line segment EG? That is given here, that is 2.5 centimeter. So this gives you 4, here you get 4, then 4, 5, 20, 4, 2, 8, 10. You get 10 centimeter squared, right? So the area of this whole pentagon will be this area plus this area plus this area plus this area. You add them up, you'll get the final area. So the final area will be, of this polygon will be 3 plus 7.5 is 10.5 plus 3 is 13.5 plus 10 is 20.5. So 20.5 centimeter squared. This is the area of this polygon. Find the area of the polygon MNOPQR. MNOPQR. In this case, you have 1, 2, 3, 4, 5, 6. This is a hexagon, right? If MP is equal to 9 centimeters, so we have values given here of different line segments, and then you have the values of these perpendiculars, NA, OC, QD, RB. You know all these perpendiculars. Now you have to calculate the area of this polygon. You will do in the same way as we did here. Okay, let's begin. Let's begin from this triangle, from the triangle OCP, from triangle OCP. Half, what's the base in this case? CP. What's the height in this case? OC. So this becomes half. What's CP? Do we know the value of CP here? No, we don't have this value CP. So how to calculate it? Well, in order to calculate the CP, the measurement of the value of the line segment CP, CP is actually the line segment MP minus, we have the value of MP. Yes, we have this 9 centimeter minus MC. MP minus MC, right? That will give you CP. Do we have the value of MC? Yes, we have the value of MC, that is 6 centimeter. So MP minus MC, that is, MP is 9 centimeter, MC is 6 centimeter, you get 3 centimeter. So from here, you get half 3 multiplied by OC, that is this height. Do we know the value of OC? Yes, that is 3 centimeter. So from here, you get 4.5 centimeter squared. Okay, now let's move to this polygon, that is NACO. This is also a trapezium. Two perpendiculars on this diagonal, that is why they are parallel, right? These two are non-parallel sides. That makes this quadrilateral or this polygon a trapezium, where this AC is actually the straight line segment that makes 90 degree with both these two parallel sides, that is the height. So the area of trapezium NACO will be half multiplied by height, that is AC, multiplied by the sum of the two of parallel sides, that is NA plus OC. Right, now we have, do we know the value of this line segment AC? No, we don't have this value here. So how to calculate AC? Well, AC is actually what? AC is MC, the length of MC that we know here, that we have here, minus MA. MC minus MA will give you AC, right? Do we have the value of MA? Yes, we have the value of MA. So this gives you MC is 6 centimeter, and then MA is 2 centimeter. So you get 4 centimeter. So from here you get half AC is 4 centimeter multiplied by NA plus OC. So NA is 2.5, OC is 3, that is 5.5. 5.5 centimeter squared, right? Now, if you solve it, you will get 2 here, then 2, 5, 10, and 2, 5, 10, 11. So this is 11 centimeter squared. 11 centimeter squared, right? Now, next is this triangle NAM. This triangle NAM. In this triangle NAM, the area will be half multiplied by base is line segment MA multiplied by height will be NA. So do we know the value of MA? Yes, we know the value of MA. So this is half. MA is what? MA is 2 centimeter multiplied by NA is 2.5 centimeter. That gives you what? That gives you 2.5 centimeter squared. 2.5 centimeter squared. Now we have then this triangle. Remember, it's we have a lot of triangles and trapezium here. Now this is this triangle QDP. Triangle QDP. So the area of triangle QDP will be half. What will be the base? Base will be this DP. What will be the height? Height will be this QD. Okay, so this is half. Do we know the value of DP? Do we have this value of DP? No, we don't have this value of DP. Then how to calculate it? Well, in order to calculate DP, you can use DP is actually equal to MP minus MD. MP minus MD will give you DP, right? So what's MP? MP is 9 centimeter. What's DP? DP is, sorry, MD, not DP. MP minus MD. I'm sorry. MP minus MD. MP minus MD. What's MD here? MD is 7 centimeter. So this gives you 2 centimeter, right? So half multiplied by DP is now 2 and multiplied by, do we have this value of DQ or QD? Yes, DQ or QD, both these two are actually the same thing, QD or DQ. So we have 2 centimeter here. So you get 2 centimeter squared. Now we have this trapezium, that is trapezium BDQR. BDQR. And why this is a trapezium? Because QD is perpendicular to the diagonal MB. RB is also perpendicular to the diagonal MB. That makes this line segment and this line segment parallel to each other. Now the line segment BD will be the height of this trapezium, because always remember, the straight line segment that intersects two parallel lines perpendicularly, will be the height of the trapezium. This BD line segment is actually the straight line segment that intersects the two parallel sides perpendicularly. That is the height. So half height means BD multiplied by the sum of parallel sides, that is DQ plus BR. Okay, What is the value of BD? Do we have this value of BD? No, we don't have this value of BD. So how to calculate the BD? Well, BD is actually MD, the line segment MD, that's here, minus the line segment MB, that is here. So you have MD as 7 centimeter minus MP as, I'm sorry, it's MB, I'm sorry. This is MD minus MB. MB is 4 centimeter. So you get 3 centimeter, right? So if this is BD is 3 centimeter. So if you put this value here, half, BD is 3 centimeter multiplied by DQ plus BR. So what is the value of DQ? DQ is 2. DQ or QD both are the same thing. So DQ is 2 centimeter. What is the value of BR? That is 2.5. So 2 plus 2.5 is 4.5. 4.5. So if you solve it, you will get, this is 3, 5, 15 and 13.5. 13.5 divided by 2 centimeter squared. If you further solve it, you get 2612.2714 and this 6.75 centimeters squared. Now the last is this triangle MBR, the triangle MBR. So this is 4th and this is 5th. The triangle MBR. In this triangle MBR, this is half. What's the base? Base is MB. What's the height? Height is RB. Do we have the value of MB? Do we know the value of MB? Yes, that is 4. So half 4 multiplied by, do we have this value of RB? Yes, we have 2.5 centimeter squared. So you get 5 centimeter squared. This is the 6th one. Okay, so the area of this polygon will be this plus this plus this plus this plus this area plus this area. So if you add them together, you get 4.5 plus 11 is 15.5 centimeter squared. Now 15.5 plus 2.5 is 18 centimeter squared. 18 centimeter squared plus 6.75 is 24.75 centimeter squared. 24.75 centimeter squared plus 5 centimeter squared is 29.75 centimeter squared. So 29.5 centimeter squared. This is the area of this polygon MNOPQR.